Hello and welcome to the AI Research Roundup. I am Alex, and today is May 8th, 2025. We are looking at a research paper titled SuperEdit, Rectifying and Facilitating Supervision for Instruction-Based Image Editing, which appeared on Hugging Face's trending list just 3 days ago, on May 5th. This paper tackles a common problem in teaching AI to edit images. Often, the instructions given do not perfectly match the example edits. The core idea here is to create better, more accurate instructions, and even use contrasting incorrect instructions to help the AI learn more effectively, using tools like vision language models, or VLMs, which are AI systems that understand both images and text. So to really see this in action, Figure 1 lays it all out. On the left, you see some impressive examples of their editing method, changing backgrounds, adding objects, even shifting image styles. Then, graphs on the right show SuperEdit outperforming other methods significantly, using much less training data. This improved learning relies on understanding diffusion priors. These are inherent traits of diffusion models, which are AI systems that create images by learning to reverse a noise-adding process. And it is trained using a triplet loss function, helping the AI distinguish between correct and incorrect edits by comparing examples. Okay, so building on that idea of better learning, Figure 2 really illustrates different approaches. Diagrams A, B, and C show previous methods often using noisy instructions, where text commands do not quite match the edits, and they try to compensate with more data or complex model parts. But Diagram D, their method, focuses on, quote, rectified instructions accurately aligned with the image changes. This approach uses a fairly standard setup, including a pre-trained UNet, a common network for image tasks, a variational autoencoder for handling image data, and see a clip, which links images to text to process these improved instructions. Alright, so Figure 3 really gets into the nitty-gritty of how these instructions are improved. On the left, in Panel A, we see the typical existing data generation pipeline. It starts with an input caption, uses a large language model, or LLM, which is an AI trained on massive text datasets to understand and generate language, to create an editing instruction. Then, diffusion models attempt the edit, but as you can see, often the background and layout get unintentionally changed. Panel B then shows their rectification pipeline, using the original and edited images, along with those diffusion priors we talked about, to guide a vision language model in creating a much more accurate, rectified instruction. So, after rectifying instructions, Figure 5 demonstrates how they, quote, facilitate supervision even further using something called contrastive instructions. Panel A on the left shows, quote, contrastive instruction construction. Here, based on a correct instruction, like add a pair of black sunglasses for the dog, the vision language model intentionally creates various wrong instructions. For example, changing the color to, quote, purple sunglasses, the position to, quote, sunglasses on the ground, or even the object to, quote, black earmuffs. Then, Panel B on the right shows the training pipeline where both these correct and incorrect instructions are used. A denoising model, which is a system trained to clean up or generate images by removing noise, learns to get closer to the edit suggested by the correct instruction and further away from the one suggested by the wrong instruction, using that triplet loss function we mentioned earlier. Now, this next table really puts these improvements into perspective. It compares their method, SuperEdit, against many other techniques on the RealEdit benchmark, which is basically a standardized test for these kinds of tasks. And the results are quite striking. SuperEdit gets top marks across the board for how well it follows the editing command, how well it preserves parts of the original image it is not meant to change, and the overall visual quality. What is truly impressive is that SuperEdit achieves this using way less training data, just 40,000 examples and a smaller model, without needing extra complex parts. To really dig into what makes SuperEdit so effective with less data, this table presents an ablation study, which is a test that breaks down a system to see how much each individual component helps. You can see that without their special instruction processing, the scores for following edits, preserving the image, and quality are lower. Adding just the rectified instructions improves things significantly. Then, adding contrastive instructions on top of that pushes the following accuracy and score even higher, showing both parts are vital for the great performance we saw earlier. So, as that ablation study clearly showed, both the instruction rectification and the contrastive learning steps are crucial. Ultimately, what SuperEdit powerfully demonstrates is that focusing on the quality of the supervision signals, essentially the guiding instructions and examples the AI learns from, is a really effective and perhaps overlooked way to get amazing results in image editing. They achieve better performance with significantly less data and simpler models. It is a really elegant solution. Well, that is all the time we have for this AI Research Roundup. Thanks for tuning in.